How about last one right here? See if you guys can find the absolute maximum, absolute minimum of this without your calculator, then we'll verify it with the calculator. Guys, this is good practice too. This was a good idea with this. This would be something on the test where it just says find the derivative, right? Chapter 3 you did derivatives. Chapter 4 we're just going to start learning what derivatives are telling us. This we'd have to do the product rule and the chain rule. All right, we want to think of this. This is t times, think of the square root as the 4 minus t squared to the half.
So 1/2. And it looks like you might be able to use the product rule.
Terry, I agree with you. We'd use the product rule.
Also the chain rule.
Yeah. Chain rule within the product rule. So we get two functions. We get t, and then we've got 4 minus t squared to the half. So derivative of t is 1. Then I multiply it by 4 minus t squared to the half. Then plus, we take the derivative of 4 minus t squared to the half. We do the chain rule. That's a half times 4 minus t squared to the negative 1/2. Then we do the chain rule. We've got to take the derivative of 4 minus t squared. That's negative 2t. Then we got to multiply that by the other t that was there. So I did the derivative of t was 1 times this, plus the derivative of this was all of this, and we had to multiply it by t. And the whole reason why we're taking the first derivative is to find our critical numbers. We'll find out where the first derivative is 0 or undefined. Our absolute maximums and minimums are going to occur at one of those numbers or at the endpoints of this. So now it's just a matter of cleaning this up a little. Is there anything we could factor out? And actually, before I do that too, I could cancel this 1/2 with that too, couldn't I? Is there anything we could factor out of both terms? Yeah, we can take out a 4 minus t squared to the negative 1/2. You can always factor something out to its lowest power. So negative 1/2 is smaller than 1/2. If we take that out, what's left if we divided this by 4 minus t squared to the negative 1/2?
Just to the first part.
We have 4 minus t squared to the first power. Because if you want, you can think of this. When you factor something out, it's like you're dividing everything by it. Right, so we're dividing this by 4 minus t squared to the half. Negative half. Right, and we're dividing this by 4 minus t squared to the negative half. So when you divide, when you have the same things, you subtract the exponent. So a half minus a negative half is 1. Over here, those cancel out, and we just get negative t squared. I'm getting a sense of deja vu. Are you? Did we do something like this before? No?
No. Chapter.
Right, but I mean taking a derivative like this. Yeah, one very similar to this. Because now this 4 minus t squared is 4 minus 2t squared. This can come down here and become 4 minus t squared to the half, or the square root of 4 minus t squared. See, that could be a great question on the chapter 3 test. Take the derivative of that and you wind up with this. Now in chapter 4, we're going to take this a step further. We're going to find our critical numbers. The critical numbers are where the first derivative is 0. The only thing that can make a fraction 0 is if the numerator is 0. So we set the numerator to 0. We also get critical numbers where the fraction is undefined. What makes a fraction undefined is when the denominator is 0. So here, take the 4 over, it becomes negative, divide by negative 2. We get t squared equals 2. So t is plus or minus the square root of 2. Here, take it over, take the square root. Get t squared is 4. So t is plus or minus 2. Okay, so those are our critical numbers. We come back here. So we got plus or minus square root of 2, plus or minus 2. So our critical numbers were plus or minus square root of 2, plus or minus 2. Let's see, we can throw 2 of them out, can't we?
On the square root of 4 minus t squared on the bottom, why
Yeah.
did you not include the square root when you?
Well, because what's the square root of 0? 0, yeah. Right, and actually too, if we did have that here, like if I had that here, what's the first thing we would do to solve?
Square root.
Square both sides.
Okay.
Yeah. But I mean, that's a good question. If you had it in there, you get the same thing. Okay, you guys see, you see we can throw out the plus or minus square root of 2, right? The square root of 2 is 1.4 something. Negative 1.4 something is to the left of negative 1. All right, so we don't need that one. So we want to test here.
But you can still use positive square roots.
Yeah, because that's 1.4.
Oh, okay, so you're just tossing it to negative.
Yeah.
Okay, thank you.
So we want to check the endpoints. We want to check negative 1. We want to check 2. All right, we want to find out what y's go with those. We also want to check out the square root of 2. All right. Oh, and then we've got plus or minus 2. 2 is one of the endpoints. Huh? So we threw out the negative. We got the positive. Can't use the negative 2 either, huh? So there's really only 3 points that are possible maximums or minimums. So we go back to the original function to find the y's. So if we put negative 1 in here, right, negative 1 squared is 1, 4 times 1 is 3. We get negative 1 times the square root of 3. So we get negative square root of 3. Or if we put 2 in here, we get 0, don't we? And if we put square root of 2 in here, square root of 2 squared is 2. 4 minus 2 is 2. We get the square root of 2 times the square root of 2, which is 2. So it looks like this one right here is our relative or absolute minimum. Right? Nothing goes lower than that out of those 3 points, and this one's our absolute maximum.
You check that with the x value, the x1, because x is x minus 1 is the minimum.
Well, no, we're looking at the y's.
Oh,
Negative square root of 3 is the smallest y. Yeah. Always to figure out if it's the highest or lowest, look at the y's. Yeah. Now, if we go, if we check this with the calculator, we can verify that. The calculator is not going to give us square root of 3, it'll give us the decimal approximation. But if we come in here and we go, and we can't use t, we use x, times the square root of 4 minus x squared. Right, and I like this, when it's a closed interval, we can even set our x's. I'll set it to go from negative 1 to 2. All right, then I'll hit zoom fit. I'll let it pick the y's that it thinks goes best. So there's our maximum there, here's our minimum here. The minimum was when t was negative 1, which is what we said it was going to be, right? And then the maximum, we can do second, calc, maximum's number 4. I got my window set, so I did it from negative 1 to 2. I'm going to try this again. I'm going to go from negative 1 to 2. Ignore the guess. It tells us 1.414, that's the square root of 2, and 2. That's our maximum. Well, Jerry, did you say take a picture of that?
yeah. So we have the same mistakes in both the questions, almost the question is the same.
Yeah. You find the first derivative, figure out what makes it 0 undefined, figure out the y's that go with those. If it's closed interval, also check the endpoints. And then one's going to be the highest, one's going to be the lowest. Shane?
So when you look at first derivative, the top, the numerator,
Sorry, I don't know your.
He's stuck in it.
that that finds our horizontal slope of the original graph, right? And then if the denominator goes to 0, could that be a hole in the graph, or would that just be an infinite slope? Is that what that-
It could be a hole in the graph, or it could be a vertical tangent line, or an asymptote. But graphs can change direction on asymptotes.
The vertical tangent line is the same thing as an asymptote.
Right, because if you think, if you had a graph, and it had an asymptote here, the graph's going up on this side, it's going down on this side. Right, so if you have a vertical line, the graph can change directions around. Okay, so I'm trying to think off the top of my head for an example, and I can't think of one, but we need to check where it's undefined. Actually, if we go back here, I actually had one. This one right here. Right, when the first derivative was undefined at 0, that turned out to be a relative maximum. It changed direction because it went to a sharp point, actually. So it's not, I shouldn't have said only just an asymptote, but it could be a sharp point. But there are times, too, where the first derivative is 0 and it doesn't change direction. Like the quickest thing I can think of for that is, just write this in the eraser. Now what if your function was x cubed? Right, we know the graph of x cubed does something like this. But the first derivative is 3x squared. Right? So the first derivative is 0 when x is 0, but the graph doesn't change direction. It goes up, it sort of levels out, then it goes up again. So it's not always when the first derivative is 0 that you have it's changing direction. It can only change direction.
But it has to change direction somewhere in there, doesn't it?
X cubed never does.
But at one end it goes down, the other end it goes up, so.
Well, no, if you're going from left to right, it's always going up. You think of it that way.
So the
Right.
slope is always
If you
positive.
change direction, it changes direction, but if you go from left to right, the graph's always going up.
Gotcha.
Now, it does change concavity, which is the second derivative. Right here it's concave down, here it's concave up.